Hi there, this is your friendly neighborhood Dr. Witten, and I am here to teach you how to do a chi-square. So let's do a chi-square. So a chi-square is an example of a non-parametric test. In other words, it's a hypothesis test that can be used with nominal or ordinal data. So here you see an example where we have frequencies by category. So in any example where you're looking at frequencies or proportion per category, you can use a chi-square. So for this class, we're going to use a chi-square goodness of fit. In other words, a one sample chi-square. So let's say I want to know for some reason which DC character my students like the best. And let's say I have 30 students in this example. And so we can arrange the data just like this. So if the options are Batman, the Flash, and Wonder Woman, I would just count the number of people who like each per category, and that would be my observed value. So that's the actual data that you have. So let's say that I have 8 people liking Batman, 5 people liking the Flash, and 17 people who like Wonder Woman. Now, the most common question I get from students is, how do we get the expected value? So unless for some reason the expected value is given, you just make each of the categories equal. So we can divide our total, which as I've said is 30, or you can just add these up to get 30, add the observed values up to get 30. And then you divide by the number of categories just to make it even. So here, we have expected values of 10 per category, right? And so this is the formula for chi-square down here. And so it is made really easy to calculate by setting it up this way, because every step that we go through is going to be a step in this formula. And when we add up the total of this, it's going to equal our chi-square value. So let's get started. So we do the observed minus the expected. And so 8 minus 10, negative 2. 5 minus 10, negative 5. And then 17 minus 10 is 7. Then we square each of those values. So negative 2 squared, that is 4. Where are we? 5 squared is 25, and 7 squared is 49. And then we divide each of the values in this column by the expected value, which again is 10. So we're going to get 0.4, 2.5, and 4.9. When you add up 0.4, 2.5, and 4.9, we get our chi-square of 7.8. So our chi-square value is 7.8. And how do we determine if that is significant? Well, for chi-squares, the degrees of freedom is k, which is the number of categories, minus 1. Here we have 3 categories, so we just subtract 1 to get 2. If you look at the table, table B in your book, you get the critical value table. So if we're looking at an alpha of 0.05 with 2 degrees of freedom, oops, that should be 0.05. I'm just going to be really clear about this. It's not 0.5. Go back. 0.05. So we have an alpha of 0.05 with 2 degrees of freedom. We get a critical value of 5.99. Since 7.8 is greater than 5.99, which is our critical value, then we can determine that there are statistically significant differences here, and yay, Wonder Woman. So I hope that helps.